going. Thank you. Sir.
Hello, sir.
ಕೇಳಿ.
Can you please
Please
present the
present the
screen?
screen.
Present
Present
screen,
screen
present.
present ಮಾಡಿಸಿ.
ನಿಮ್ಮ PPT screen, sir.
ನಿಮ್ಮ
PPT screen, sir.
YouTube
Yes, sir.
ಎಸ್ ಸರ್ ಬರ್ತಿದೆ. ಓಕೆ.
ಏನು ಸರ್ ಬರ್ತಾ ಇದೆ. ಅದು ಯೂಟ್ಯೂಬ್ ನಿಲ್ಲಿಸಿದ್ದಾನೆ. ಯೂಟ್ಯೂಬ್ ಸ್ಟ್ರೀಮ್ ಆಗ್ತಿಲ್ಲ, ಅದು ನಿಲ್ಲಿಸಿದ್ದಾನೆ. ಸಾಕು ಬಿಡಿ, ಅದೇ ತಲೆ ಕೆಟ್ಟಿದ್ದಾನೆ. ಕಾಣಿಸುತ್ತೆ. ಮೀಟಿಂಗ್ ರೆಕಾರ್ಡ್ ನಾನೇ ಮಾಡ್ತೀನಿ.
ಸ್ಪೀಡ್ ಟೆಸ್ಟ್ ಬರ್ತಾಯಿಲ್ಲ, ಸ್ಪೀಡ್ ಟೆಸ್ಟ್ ಮಾಡೋಣ.
ಬಿಡಿ ಬಿಡಿ, ಆಗ್ತಿದೆ, ಸ್ಟ್ರೀಮಿಂಗ್ ಆಗ್ತಿದೆ ನೀಟಾಗಿ. ಅದು ಎಲ್ಲಿ ಬರ್ತಾ ಇಲ್ಲ ಅಷ್ಟೇ, ಸ್ಟ್ರೀಮಿಂಗ್ ವಿಂಡೋದಲ್ಲಿ ಬರ್ತಾ ಇಲ್ಲ, ಕಂಟ್ರೋಲ್ ರೂಮಲ್ಲಿ. ಬಟ್ ಇಲ್ಲಿ ಸ್ಟ್ರೀಮ್ ಆಗ್ತಾಯಿದೆ ನೀಟಾಗಿ ಯೂಟ್ಯೂಬ್ ಲಿಂಕಲ್ಲಿ. ಸಕ್ಸಸ್ಫುಲಿ ಡನ್.
ಡಿಸ್ಕನೆಕ್ಟ್ ಆದರೆ ಸ್ಮೂತಾಗಿ ಆಗುತ್ತೆ ಸರ್.
ಹೇ, ನೀವು ಸ್ಟ್ರೀಮ್ ಮಾಡಲಿಲ್ಲ ಅಂದರೆ ಆಗ್ತಾನೆ ಇರುತ್ತೆ.
ಹೌದಾ, ರೆಸ್ಟ್ರೀಮ್ ಮಾಡಿಲ್ಲ ಅಂದರೆ ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗಿದೆ.
ಆಗೋದಿಲ್ಲ.
ಅದಕ್ಕೆ ನಾನೆಲ್ಲ ಯೂಟ್ಯೂಬರೇ ಮಾಡೋದು ಜಾಸ್ತಿ.
8 ಅವರ್ಸ್ ಹೋಗ್ತಾ ಇರುತ್ತೆ ಸುಮ್ಮನೆ. ನೀಟಾಗಾದರೆ ಸಾಕು.
ಗೊತ್ತಾಗಿದೆ.
ಸ್ವಲ್ಪ ಡಿಲೇ ಇರುತ್ತೆ ಅಲ್ಲಿ.
ಸರ್ ಹೇಳಿ. ಹಾಂ ಹೌದು, ಲಿಂಕ್ ಕಳಿಸ್ತೀನಿ ನೋಡಿ ಯೂಟ್ಯೂಬ್. ಓಪನ್ ಆಗುತ್ತೆ ಕಳಿಸ್ತೀನಿ ನೋಡಿ. ಗ್ರೂಪ್ ಮಾಡಿ
ನಾನು ಮಾಡಿದ್ದೆ. ಓವರ್ ಮೈಕ್ರೋಫೋನ್ ಎರಡು ಮಿನಿಟ್ ಮಾಡಿ ಇಂಟ್ರೊಡಕ್ಷನ್ ಈಗ ಕೊಡ್ತೀವಿ. ಸರಿ ಇಷ್ಟು ಸಕ್ಸಸ್ ಏನಿದೆ ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಸರ್ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಇದು FDP. ಬರ್ಕೊಳ್ಳ ಫುಲ್ ರೆಕಾರ್ಡಿಂಗ್ ಕೂಡ ನಾನು ಇಡ್ತೀನಿ. ಶುರು ಮಾಡಿ ನಾವು Sir, shall we start?
We can start.
For this slide on advanced artificial intelligence, machine learning technologies. I also like our previous speaker, Dr.
Dr.
T.C.
Master.
PhD from IIT, professor and head EC department. And now I request Professor Panchami Madam to give a small introduction about this.
A very good morning, everyone. For today's session, we have with us Dr. T.C. Manjunath. He has pursued his ME at Government Engineering College, Ahmedabad, and PhD at IIT Bombay. He has vast experience of 35 years in teaching as well as industry. He is also a member of BOE and BOS for many autonomous institutes. His areas of interest includes control systems, robotics, signals and systems, and mechatronics. Currently, he is heading the Department of Electronics and Communication Engineering at Dayananda College of Engineering, Bangalore. It's a great honor for us to have you, sir. On behalf of the department, I welcome you. Over to you, sir.
Hello.
Yes, sir.
Yeah, can I start?
Yes, sir. Please go ahead.
Good morning to one and all. First of all, I would like to thank all the management officials of Vidyarthika College of Engineering for having considered me as one of the webinar speakers for this 5-day event. I would like to thank Professor CM Patil and his entire team of EC department for hosting this. I would like to give a brief, actually this would be a 3-day session, mine. And to start with, I would like to give something about advances in AI, machine learning and robotics from the macro stage to the micro stage and finally to the nano stage. This would be the first day presentation, that is introduction. I would like to proceed the presentation in this following sequence. First is what is introduction, automation and robotics, industrial automation 4.0, or what we call as industry 4.0, then Asimov's laws of robotics and some forward and backward kinematics, workspace concepts, task planning and manufacturing concepts, and the types and generations of robot with the brief applications, and followed by the conclusions. And this would be the second day presentation, and this would be the third day presentation. And actually what I would do is I would like to mix up some of the 3 presentations and interpreting it in a random fashion in these 3 days, so that the link will be established between the 3 between the 3 presentations. And also I'll be showing some of the videos so that it will have a greater impact on the audience. First of all, something about overview about what is automation and artificial intelligence, machine learning, and robotics, which are the hot topics in this current scenario. As you all know that more than 2000 years ago, the great Greek philosopher Aristotle said, then certainly if each tool could act on received instructions or even guess the orders before performing the task, and if the shuttle could weave and the ether could play by themselves, then no master would need any helping hand or servant. See, what do you mean by this quote? This quote says that more than 2000 years ago, Aristotle had thought that a future automation age was going to begin. Yes, what he has thought was right at that time. As years rolled by, what happened first century, second century, third century, like that 17th century, 18th century, etc., etc. As years rolled by, industrial revolution broke out in England, as a result of which numerous machines were invented, and that led to the automation age. Now you should know what is automation. So automation can be defined as a technology that is aimed at replacing ourselves, that is human beings, with automatic machines called as robots, or it can be artificial intelligence systems or the smart intelligence systems, where it can be an industrial plant or it can be in any process control in order to manufacture a particular product capable of working without human intervention. Take for example an automobile industry or a car industry, where a car is entirely manufactured using robotic, but that means you can say it's a technology which is concerned with the use of mechanical, electrical, instrumentation and computer-based systems in the operation and control of production, or it can be a process. It can be any type of process. We can go for the automation process. So as years rolled by, what happens? Science, engineering, and technology started improving. In the 1800s, in the British, in the United Kingdom, and in the United States, the Industrial Revolution broke out in the various parts of the universe. As a result of which, a large number of automatic machines were invented, which made the life of the human beings more comfortable. Example, in the United States, the airplane was invented by the Wright brothers, the steam engine was invented by James Watt. Numerous inventions were made across the globe. At bullock cart stage to the automobile stage. So people all over the globe started to moving towards the automation age that is capable of replacing human beings with automatic machines. That is what is called as automation. So thus the automation age began in the early 1800s. Now what are the advantages of automation? See, there is a lot of improved quality. That means they increased, for example, if you go to an automobile manufacturing unit, the entire car is being manufactured by the robots, so the production rate can be increased and the cost per unit will be less and the quality of the finished product will be very very good and the consistency will be there and time savings, then enhanced operational efficiency, better governance, reliability is there, then reduced turnover times, reduced cost of operation, and the GDP, or what we call the national economy, will rise. So main advantage of automation is the production, the industry 4.0, or starting from 1.0 to 4.0. See for example, that's what I wanted to reiterate, that the if you go for automation, one of the main advantages is the production rate can be increased and the cost per unit will be less. For example, if one car has to be manufactured, nearly hundreds of human beings will be required. The same car can be manufactured by a number of robots, so that the production rate can be increased. Now, there are types of automation. So you can broadly classify them into two types. One is called as it was not is what is called the soft automation, which is the modern days. So this hard automation is also called as the fixed automation, and it is used in the places where volume of production is very high. That means same product has to be manufactured in huge quantities in bulk. For example, you take a soap manufacturing plant, where is the product design is the same, so we can go for what is called as hard automation or fixed automation, where if you want to change the design of the product or the soft, then you have to change the entire setup. Then hard automation will flop. Then you have to go for what is called as soft automation. Now we are in the era of modern. Now we are in the era of soft automation. So there are varieties of soft automations. One is the programmable automation and the flexible automation and FMS, what we call as the flexible in manufacturing systems, and the industry 4.0. Programmable automation means, for example, in the hard automation, in order to manufacture a particular product, one particular setup is needed. If you want to change the setup, then if you want to change the product, then you have to change the setup, so which involves cost. So by using the same setup and by varying the software or the program, then you can design a product. That is one of the advantages of programmable automation. So as a result of which, there will be flexibility in the manufacturing different sizes and shapes of products. So manufacturing of a variety of products of different sizes, shapes, volumes, by just changing the software and without changing the physical setup of the system, is what is called as programmable automation and the flexible automation. So it means that same physical setup is used to manufacture a variety of products. How? By just changing the program. Enter one program, one product will be the same physical setup is sufficient to manufacture a product of variety of sizes. So as a result of which, what happens, there will be flexibility in manufacturing and the production rate also can be increased. And this is how the evolution of automation started from the early 1800s to the current 21st century. First, the fixed automation was there, then came the manual or the changeover of the programmable automation. Now we are in the era of fully flexible automation. That means that is the quick seamless conversion between product and the processes. You can change. Suppose, for example, you take a car manufacturing industry. For example, you take this Maruti Udyog plant. The entire Maruti Udyog plant in the Haryana Gurgaon plant is around 2 kilometers, and there are a number of robots are there on the left side, number of robots are there on the right side. Say, for example, you want to manufacture a Ertiga model. Just change the software and the Ertiga model will be, the assembly line will be set up to manufacture the Ertiga model. So you have to stop the production of the Ertiga model, you have to go for Alto. Then what you do, you just enter the software for the design of the manufacturing of the Alto models. So the entire assembly line will be set up so that there is a flexibility in manufacturing, and variety of products can be manufactured in 24 hours. So that's what I wanted to tell you. Flexible automation means in order to manufacture a particular product, a product is in a program or software is entered, and the product is manufactured, and there is no need to change the physical setup of the system, unlike in that of the hard automation. In hard automation, what we are doing, you have to change the physical setup in order to manufacture a particular product. Example, you can take the mechanical manipulators, or they are also called the robots, which are interfaced to a computer to do a variety of tasks. And here, this is the international relation between the cost effectiveness and the relationship between the three types of automation. So this flexible automation comes in between the fixed and the programmable automation. For example, if you see the cost effectiveness of different types of automation, if you want to go for very low volume of production, say I want to manufacture one or two products, then there is no need to switch on the entire industry. Then you can go for what is called the manual labor. It is feasible. Between volume 1 and volume 2, it's medium. Medium, you can go for medium volume of production, you can go for software automation, like that. So this is the cost effectiveness of different types of automation. One advantage of this type of automation is if the cost per unit will come down. For example, if you take if you manufacture a particular product in huge volumes, that's in the bulk, then the cost per unit will come down. If you go to a shop and you ask for one CD, you will take 10 rupees. On the other hand, you ask a bunch of 100 CDs, you will give it at 5 rupees or 6 rupees. That is what is called as the cost per unit. In fact, you can see this cost effectiveness can be seen in the soap manufacturing industry. Once I had got an opportunity to visit Hindustan Sibagegi, where the Synthol soap was manufactured. So there, since the cost per manufacturing of one particular soap is just 7 paisas, whereas it has been sold for around 20-25 rupees, because they have to incur the marketing cost and the manufacturing cost, labor cost, etc., etc. So the advantage for flexible automation is, if you want to manufacture a product in huge volumes, the cost per unit will come down, and that is feasible. So flexible automation is a type of manufacturing automation which exhibits flexibility. It means you can manufacture varieties, different products in shorter times. Also, you can go for what is called as parallel processing. So if you have a one assembly line, one product will be manufactured. Another assembly line, another product will be manufactured. So parallel processing is there in this flexible type of automation. So main feature is allows a production of a variety of parts in small units, or it can be in batches. Some of the main features are, but only the advantage is the disadvantage is that it needs a very high capital investment. Of course, it is a one-time investment, and since we make a one-time investment and you make the entire setup ready, the same setup can be used to manufacture a variety of products and of different sizes, shapes, etc., etc. Skilled labor is required to operate the machines. Nowadays, with the Industry 4.0, that skilled labor also is gone. Entire system is automated. Recently in Japan, an entire industry was automated, which is called as industrial automation. There are no human beings in this industrial plant in Japan. I think it's in Mitsubishi plant. There, the entire product is being manufactured using robots. There are no human beings inside that. Again, the product is being, after the manufactured product is being manufactured, it is being transported to the trucks, again using what is called as the automated guided vehicles. So continuous production is there, variety of product designs is there, flexibility and adaptability in manufacturing techniques is there. They can use sophisticated computing and control systems, use of parallel processing and advanced simulation packages improves the efficiency. In fact, the product design, everything is done in the computer itself, in the simulations. For example, in AutoCAD process. In the AutoCAD, what you do, the entire product is simulated on the computer. On the computer only you design the product. Once the product is being designed and tested on the computer using the software, then you will transform into the reality stage using the automatic machines or the AI machines or the robots. So this FMS, flexible automated systems, consists of a variety of workstations, series of workstations like human beings. Each workstation is nothing but a human being, and all are connected to a material handling and storage systems. So all these workcells are connected to a central processing unit, which is used to control the various activities that takes place in the system. This entire thing, FMS, can be called as the CAD CAM SIM, or computer aided design, computer aided manufacturing, or the computer integrated manufacturing in the AutoCAD, which is nothing which is having a combinations of many programmable automations will lead right to flexible automation. There I've shown that one computing system is used to manufacture one product, that is one programmable automation. Another computer is used to manufacture another product, another programmable automation. The entire thing is centrally controlled by a central processing unit or a master unit. So this is what is called as parallel processing unit. Parallel processing concept to manufacture a variety of products, which makes use of flexible automation and the mechanical concepts such as the CAD CAM SIM. And this is one a beautiful concept, beautiful photograph where a number of products are being manufactured in different sizes, shapes, using the same setup. The same robot is there. That robot is used to manufacture one product because you entered one program. Enter another program, it will manufacture another product. So that there is a flexibility in the manufacturing system. This is what is called as a CAD CAM. This resembles that of a olden day, like in the 70s, in the 80s, this machine shop or the shop floor in an industry. If you go to a shop floor or an industry in the olden days, you used to see one worker sitting in one place, another worker sitting in another place, another worker in another place. Each worker is doing some one or the other operation. Similarly, instead of that human, if you go for that concept, then it will take a lot of time to manufacture a particular product. If we go for this industrial automation, then the production rate can be increased. One simple example I'll give you in Tata Indica, this Maruti Udyog plant in Haryana. So the entire plant is working for 23 and a half hours a day. 23 and a half hours a day. That means only there are three shifts. Shift 1, 10 minutes gap. Shift 2, 10 minutes gap. Shift 3, 10 minutes gap. Even though the entire plant is working for 23 and a half hours, they are unable to meet the supply and the demand. In fact, the Maruti requires, actually the plant needs, the country needs around 2,000 cars a day to be manufactured. Even then, the entire plant, if it is in operation for 23 and a half hours, they are manufacturing only 1,200 to 1,300 cars. That means 800 cars, the deficit is there. They cannot meet the supply and the demand. So that's the main advantage of industrial automation. Think about if human beings were used to manufacture a particular product, then you would have to wait for years together, for months together to purchase a particular product. So that is the main advantage of industrial automation, where the production rate can be increased. You can get the product at a faster pace. Some of the examples of automation process I would like to give in this context: mechanical assembly lines, the numeric controlled machines, the CNCs, the computer numerically controlled machines, the feedback control systems, the assembly process, the assembly line automation, for the weather forecasting. This is also a very good procedure, the computer automation for weather forecasting, and the automated manufacturing, computer systems for decision making, process control, what is called as a mechatronics, then automated power production in retail. In retail means in shopping malls, etc. All those things. Mining, the video surveillance, highway systems. Now with the introduction of the automatic toll, the entire highway systems is being automated. Waste management, the business process, then the home automation using the IoTs and all, the laboratory automation, logistics, the industrial automation, the industrial robotics, the PLCs, and then the defense places, the exploration, space exploration. For example, our ISRO has launched the Chandrayaan. That's one of the beautiful automation concept. The medical application, which I would like to explain these modeling concepts, etc., in the tomorrow webinar. So currently, 20th century, almost in each and every field in the universe, the process automation is being used, which is that's why it is called as the industrial automation. Now, this evolution of automation is into the robotics age. In the earlier days, mechanical systems, AI systems were not that much developed because the technology was not that much developed. So I would like to take you how the automation age evolved into the robotics age and the AI age. So this automation age evolved further into the robotic age in stages, for example, 50s, 60s, 70s, etc., whereby step by step the machines started to take over the work which were done by the humans. In the earlier days, human beings were used to manufacture a particular product in a factory or an industry. Stage by stage, what happened? The machine started to take over because the industrial revolution picked up at a faster rate. So thus the age of robots, the machines, began in the mid 1950s. So as years rolled by, the science, engineering, and technology started to improve. See, in the United States, in the Bell Labs, diodes were invented, IC chips were invented, the microprocessors, microcontrollers, the PLCs, the computers were invented, the number of transistors per chip, that is the LSI, very large scale integration process, as a result of which the digital computing age started with the increase in machine intelligence. So this automation age evolved into the robotics age. Finally, it evolved into the artificial intelligence age, which began in the early 2000s. Now, you should know what is the difference between robotics and artificial intelligence. First, let me tell you about what is robotics. See, this robotics is defined as that branch of engineering which deals with the study of different types of robots, their simulations, their designs, their constructions, operations, performance, applications, etc. And you can say this is an interdisciplinary field which mixes various engineering disciplines into one. That means electrical, electronics, computer science, instrumentation, mechatronics, biosciences, biomedical instrumentation, IT, mechanical, production, automation technology, the mathematics, if you go for the modeling, then computer programming and its environment, then computer architectures, the physics, the dynamics, mechanics, kinetics, kinematics, hydraulics, pneumatics, cybernetics, which is nothing but the science of closed loop servo systems, the motion control, the communications, the analog communication, digital communication, mobile communications, optical satellite communications. If the robot is sent to the planet Mars or the moon or this one, then you go for satellite communications, the digital technology, because you are making use of the computing process, then image processing, since you are making use of the cameras, the computer vision, the computer graphics, pattern recognition, DSP, AI, expert systems. Expert systems are systems which will work like humans in all fields, which is the sixth generation of the systems. Information technology, human factors, design, simulation, and many other fields into one subject called as robotics. It means that if we study all these subjects, it means that we have studied one subject called as robotics. That's why we can say this: robotics is an interdisciplinary field, which is a technology for the future. It's or you can some countries define it in a different manner. So, for example, the one of the country, I think UK, they define robotics as the combination of machine tool technology and computer science, and in the form of industrial automation, and is a technology with the future and for the future. And also it can be defined as that branch of technology which deals with the design, construction, operation, and applications of robot. This field, robotics field, overlaps with electronics, AI, machine learning, CSE, mechatronics, and in the nanotechnology, which I would like to tell about tomorrow, and the bioengineering, or what you call as the biorobotics. What is the main aim? The main aim or the goal of this robotics scenario is to design intelligent machine like human beings that can help and assist humans in the day-to-day life, help them to remove get rid of the fatigue, tiredness, etc., and keep everyone safe and automate the process of production. So robotics helps develops the machines that can substitute for humans and replicate humans in the form of what is called as imitation learning. Imitation learning means learning by looking at one word robot. For example, you take any word in English, it is derived from Greek and Latin. For example, you take a cockroach, it is derived from the word Americana pariplanata, like that. So, who coined the word robot? So, the word robot was coined by the Czechoslovakian playwright in 1920 in his play called as Rossum's Universal Robot. In fact, he designed a play in 1928, drama in a theater. There he showed that play around for 1.5 hours, I think. And in that play there are machines which will work like human. So he called those machines as rubuta or rubutnam, which is a Czechoslovakian English scenario to coin the word as robot. So robot came from the Czechoslovakian word called as rubuta or rubutnam, which means in Czechoslovakian meaning, it means that a way a forced worker or a slave or a laborer strictly obeying master orders. How will obey master orders? By programming or by teaching. Who is the master? The master is the programmer. So robot is nothing but a slave or a forced worker strictly obeying master orders by programming. So in this play, robots are machines that resembles man, but they work tirelessly and are small artificial creatures strictly obeying master orders. So this Carol Capek's play was largely responsible for the development of the modern day robotics. And like our Newton's three laws of robotics, Isaac Asimov, one of the science fiction writer, he framed the three laws of robotics. Even today, these three laws of robotics are very, very popular. In fact, many of the science fiction movies also had come based on Isaac Asimov's three laws. The law one says that a robot may not injure a human being or through inaction allow a human being to come to the harm. So that it is sense that robot should not injure a human being. If human beings will fight each other, like that, robot should not fight with themselves, or robot should not fight with the human and harm them. A robot must obey orders before it is given by human beings, except where such orders conflict the first law. If you see this Terminator movie, Schwarzenegger in the Terminator 2 Judgment Day, so there the robot is disobeying the master's orders. It goes against the human mankind and tries to eliminate the mankind. That should not happen. Then it will conflict the first and the second law. A robot must protect its own existence long as such production does not conflict with the first or the second. It should have its own identity. That is the meaning of that. In fact, before this coining of these three laws, also had framed the zeroth law, in fact is not in existence, and this zeroth law was evolved into three laws as law 1, law 2, and law 3. So why Asimov put the three laws of robotics in the order he did? It should not harm human beings, you should obey the orders, you should protect yourself and everybody's. So in this birth century, birth century of Isaac Asimov 1920, these three laws of robotics have a profound influence on our thinking in terms of AI and the creation of what is called a sentimental thinking machine. So we can be called as Sir Isaac Asimov is being called as the father of the world robotics. What is a robot? See, different countries, different organizations, define robot in different way. For example, the IEEE standards, that is the Robotic Institute of America, defines a robot as a various objects, tools, materials, or specialized devices to various programmed for the performance of a variety of tasks. That means the same machine is being used to perform a variety of tasks through by changing different programs. That is what is called as flexible automation. This Japanese Institute of Robotic Association defines a robot as a replica of a human hand. How a human hand is there, that replica of a human hand, the Japanese has defined. If you take our Indian scenario, that is CARE, which is the only robotic institute in the country, that is Center for Artificial Intelligence and Robotics, which is a DRDO concern. So they define it as, in fact, Vidyasagar, he defined it as a mechanical device which can move in different directions relative to the base and controlled by a computer. Which are those different directions? Six possible directions: the base, shoulder, elbow, the yaw, pitch, and roll, which is at the wrist. Now, there are two types of robots basically. One is a fixed robot or the stationary robot, another is a mobile robot or a moving robot. You can see that in the fixed or stationary robots, the robots are bolted or fixed, which is stationary and cannot move. In the mobile moving robot, the robots can move in the XY plane, that is on the floor from one point to the another point, from X1 comma Y1 to X2 comma Y2. In fact, all these four systems which is shown in this slide was designed and developed by our UG and PG students. All those four were the UG and PG projects. Now, coming to automation in robot. So you know that automation is there, defined in two types, categorized into two types. One is hard automation, soft automation. Out of the two types of automation, our robotics belongs to the category of soft automation. So what is this robot? You all know that we already explained that it's nothing but a mechanical system which are controlled by software, and you can perform a variety of tasks without human intervention, and you can also, without changing the physical setup of the system, you can use the same robot for manufacturing a variety of products, multitasking, different product manufacturing. How? By just change the software. And thus automation in robotics became too closely related to technology. Technology. In fact, in Asan Malnad College, there is a MTech course, MTech specialization in industrial automation and robotics. So this automation evolved into two stages. One is partial and complete. Partial in the earlier stage, where the technology was not that much developed. Now we are in the era of complete automation, or what is called as smart automation, the smart factory or the smart in the industry. So this is a difference between a human hand and a artificial robot hand, which is according to the definition of the Japanese Institute of Robotic Association. So a replica of a human hand is nothing but a robot hand. See, every particular movement is having 1 degree of freedom. Okay, our human hand has got 27 degrees of freedom. That means if you take at the shoulder level, it can move in three directions. That is the left, right, yaw, the up, down, pitch, and the shoulder can roll. Similarly, in the elbow, there are 2 degrees of freedom. According to as there are two bones called as the radius and the ulna, which makes you elbow to move up and down, bend up, bend down, and it can also rotate. Similarly, at the wrist, there are 2 degrees of freedom. Strictly speaking, that is the left is yaw and up down is pitch, and this is also a roll motion. In the fingers, there are 20 degrees of freedom. Totally, a human hand has got 27 degrees of motion. That means if you want to design a robot, your human hand, you require 27 motors or 27 actuators. There I can just seen you shown a typical human hand and an artificial robot hand. You can see that small micro motors, nano motors are fixed on the fingertips, which moves at very minute angles in the form of say 1 micro degree per step. So a typical robot hand, it can consist of the base, the arm, and the end effector. So the base is bolted to the floor, and the arm is connected to the shoulder, and the end effector is connected to the wrist. So there, this is exactly looking like the typical robot hand. That's also called as a mechanical manipulator. Why they call it as a mechanical manipulator? Because every time you move from one point to another point, the position and the orientation of x1, y1, z1 changes. That's why it is called as a mechanical manipulator. So you can say that the mechanical manipulator is made up of links and the joints. Now, what is our human hand? If I take. What is the human hand made up of? The human hand is made up of bones and the joints. That is the elbow joint, the shoulder joint, the wrist joint. In between the wrist joint and the elbow joint, there is a bone. Similarly, in the mechanical sense, this bone can be considered as a link. So we should know what is the difference between a link and a joint. So what is a link? What is a joint? In fact, a joint is nothing but a junction around which the two links will rotate with respect to each other. So that means this is a rotary motion. A joint is nothing but a junction around which the two links will rotate with respect to each other or translate with respect to each other. So there are two types of motion. One is called as a rotary motion, another is called as a telescopic motion or the prismatic motion or the linear motion. In some places when you need linear motion, you can convert the rotary motion into linear motion using a rack and pinion device. Okay, now coming to this end effector. Why is this end effector? This end effector is nothing but the wrist having a number of fingers. Okay, why it is called as end effector? Because the effect is very much high. If the end effector is not there, the effect is zero. It is no use. It cannot do any work. That's why it is called as a end effector. It's a device which is attached to the end of the arm. There are two types of end effectors. One is called as the tools, another is called as the grippers. See, this end effector can move in three directions. One is the left-right motion is called as the yaw, the up-down motion of the wrist is called as pitch, and the rotation of the wrist is called as the roll. So these end effectors are called so because they are the devices which are attached to the end of the arm, and they are useful for performing a variety of tasks. If you take our human hand for what purpose it is used? Either for writing or for eating or for doing programming or for doing any useful work. Similarly, in the mechanical sense, it is useful for doing a varieties of work such as pick and place of objects, drilling, welding, puffing, painting, grinding, etc. As I already told you that there are two types of grippers, two types of end effectors. One is called the gripper, other is a tool. So grippers are the universal of all end effectors. They are used to grip, grasp, pick up object from one place in one position and orientation, keep it in another place in another position and orientation. Used for a pick and place of objects. Normally, two fingers are sufficient for gripping any particular object because the scientists in the world, the scientists all over, researchers all over the world have proved that two fingers are sufficient to grip an object. One is the thumb and another is the forefinger. That's why the thumb is the most powerful. So two fingers are sufficient. Majority of the robots in the world today are having two fingers because researchers have proved that because of the aesthetics, two fingers are sufficient. For example, if you take a duster and how to take it, how you take the thumb and the forefinger and you rub the board, right? So two fingers are sufficient to hold it in the proper direction and with the center of at a particular center of gravity. Okay, that's why in that Mahabharata, this one, why did Dronacharya ask Arjuna, Ekalavya, the thumb? Because the thumb is the most powerful. So the thumb and the forefingers are too sufficient to grip any particular object. This is the gripper. Now in the industry, what they do, they remove this gripper, unscrew. They will remove this, unscrew it, and they will attach a device. That is called as a tool. So it can be a grinding machine, or it can be a spray painting gun, or it can be a welding torch, or it can be a drilling machine. So what are tools? So the tools are nothing but specialized devices which are used to do specialized operations such as spray painting, welding, drilling, buffing, grinding, etc. So there is a difference between a tool and a gripper. Okay, tool is used for doing some operation, right? And a gripper is used for picking and placing of a particular object in one position and keeping it in another position and orientation. Like how computer, the different parts of a computer and the technical parts of a robot. Five important points of a robot are there. One is a AMS, what you call as a mechanical structure, articulated the mechanical structure is jointed like human beings, how the bones and joints are joined to form the entire structure like that. And this articulated mechanical structure has to be moved. How will you make it move? By making use of actuators. What are the type of actuators? You can see electric motors, hydraulic systems, or the pneumatic systems, actuators. Now the power is produced at one point, you have to take it to another point. What you do, you can go for transmission devices such as the gates or the pulleys or the chains, sprockets, wheels, etc., etc. Sensors are very much useful to make the system closed loop. Like we human beings has got a number of sensors. Eyes acting as the most effective sensor for getting for becoming a closed loop feedback servo system. For see one best example I'll tell you. See, we pick up a particular object, a duster or a pen. The moment we human beings pick up a pen or an object, we stop further gripping. The fingers stop further gripping. Why? The moment you start, your brain gives a signal to the fingers to start picking up the pen. The moment you touch the pen, you stop further. Why? Because signals are being given from the skin, which are acting as a tactile sensors and given to the brain, which in turn the brain gives a signal to the finger motors to stop further pressing of the pen. This is how you incorporate thinking in the mechanical machines. Okay, and the controller. Controller is nothing but the brain of the system, which is nothing but a microprocessor, the microcontroller, or a PLC, or it can be any type of computer controlling device. So you should know. As I told you, automation age, you are into robotics age. Now we are in the era of AI. What is this AI? AI is defined as that part of computer science and information science with the characteristics with which we associate with intelligence in human behavior, that is, understanding the languages, learning, reasoning, problem solving, and so on. And this is concerned with understanding the nature of intelligent action to perception. So, artificial intelligence, we can say that we human beings are natural human beings working with natural intelligence or born intelligence. Robots are nothing but artificial humans working with artificial intelligence. Like how we are working the same replica the machines should work. So we have got human behavior, we understand different types of languages, the machines also should understand different types of languages. We learn, the teacher teaches the student, and we go for so many FTPs and all. We learn, that learning mechanism is there in our brain, and the learning mechanism should also be incorporated in the machine. Reasoning, problem solving, the teacher gives a problem to the student, and what will the student do? He will start solving the problem. If the same problem is given to a machine or a robot, how will it solve? So various types of algorithms, machine learning algorithms, has to be incorporated into the system to solve the particular problem and to get its solution, and to understand the nature of intelligent action to perception. So like how we human beings are very intelligent, the machines also should become very intelligent. So by incorporating a number of learning algorithms, so we can also define, AI can also be defined as the ability of a device to perform functions that are associated with human intelligence, such as reasoning, planning, problem solving, pattern recognition, perception, cognition, understanding and learning, position of sense such as light, sound, touch, and feel. For example, you take the touch. See, the moment we touch any object, we feel that we have touched, because there are tactile sensor or touch sensor, the skin all around the body. In the same scenario, if a machine is there, if you give an instruction to a machine to pick up a particular object, it goes and picks it up. The moment it picks up the object, it should stop further gripping. Otherwise, the object might get damaged. Say it's an egg picking operation, so it has to be very delicate operation. So a sensor should be mounted inside the fingers. So when the moment the system, the fingers touch the object, feel, it should stop further gripping. So that much intelligence has to be incorporated to make the machine intelligent. So United States intelligence is defined AI as the collective attributes of a computer, a robot, or other device of performing functions such as learning and decision making. See, decision making, we know. For example, we are driving a car. So when we are driving a car, if any obstacle comes in between or in front, the human brain takes a decision to overtake, to avoid the obstacle, circumvent the obstacle, and move towards the destination. That decision making capability is there in our human making, in our human being. The same concept, how we incorporate in the machines by making use of programming skills like if loop, for loop, etc. Decision making symbols, all those can be utilized. That is what is called as AI. So AI is aims at developing robotic systems that appear to behave intelligently or think like humans. So often this is described in developing robots that think like us. Of course, it is very, very difficult to design a system which will work like humans in all fields. Therefore, human beings are called the super robots. Modern robot concepts, control concepts such as vision, speech, tactile sensing have got their roots in AI research. So, a robot can be defined as considered as a fully automatic.
ಇಂಟ್ರಪ್ಟ್ ಮಾಡೋದ್ರಿಂದ ಬರ್ತಾರೆ ಅಂತ ಹೇಳು. ಮೈಕ್ ದೂರ ಕಿಟ್ಕೊಂಡು ಮಾತಾಡ್ಬೇಕು. ಈಗ ಬರ್ಬೇಕು. ಏನಕ್ಕೆ ಹಂಗಾಗುತ್ತೆ? ಮೈಕ್ ಹತ್ರಕ್ಕೆ ಹೋಗ್ಬಿಡ್ತಾರೆ ಅನಿಸುತ್ತೆ. ಡಿಸ್ಟೆನ್ಸ್ ಫುಲ್ ಕಮ್ಮಿ ಮಾಡಿದ್ರು.
Stewart then and Gary Kasparov. So the fight was between Gary Kasparov
ನೋಡಿ ನಮ್ಮ ಟ್ರಸ್ಟ್
just playing robots. So there you can see how
ಮಾಡಿ ನಮ್ಮ
can think of only 6 moves a second. His intelligent quotient is such that his brain can think of only 6 moves. I can move the soldier or the elephant or the rook, soldier or the horse this way like this. In 1 second he can think of 6 moves. But the supercomputer was could 1 million moves a second. That much was the computing power. In fact, supercomputer defeated. The moment Gary Kasparov was about to take a pawn and about to keep it in the chest, that particular position, already the machine which is connected to the robot and it used to keep the opposite element in that position. It used to knock him down. That much is a machine intelligence. How machine intelligence? More amount of thinking, algorithms, decision making, parallel processing techniques, cloud computing. That this everything is being incorporated, as a result of which the machine intelligence becomes more and more, and it is going to defeat the humans. And see, any AI in robotics, there are 15 important goals. The most important 15 goals. One is called as a planning, other is called as a problem solving, natural intelligence, machine intelligence, understanding, cognitive, the cognitive networks you might have heard of that, learning algorithms, the vision, the speech, reasoning, and the physiologic, the neural networks, expert systems, programming skills, expert systems, the systems which can work like humans in all fields. We have speech. Recently, you might have heard of the speech processing. The Japanese have invented the sixth generation of computers. There is no keyboard at all. Only the display is there. You go on speaking, it will appear on the screen. That is speech to text conversion, cognitive machine intelligence, problem solving, planning. Planning is very, very important. It is what is called robot task planning. One simple example I'll give you. See, in this class, what the teacher do? Teacher takes up a particular topic and he teaches the student very well. Okay, and then he or she gives a problem to solve. Can be on any topic. The moment a problem is being given to the student, will he start directly solving the problem? No. First, he writes down the data, what is given in the problem. Then he starts to analyze. Then he starts to plan how to attack the problem, how to solve the problem, what formula I have to use, and how I have to get the answer. So, planning is an important topic in artificial intelligence. So, planning means deciding on a course of action before acting. Before the robot task, the particular task, how the task has to be done in its workspace has to be planned. This is what is called as planning, right? For example, I can say the task is a very complicated task. Take for example, it has to go from the Earth in the spaceships up to the moon, Chandrayaan, and the robot has to come out of the Chandrayaan planet and it has to Chandrayaan spaceship. It has to land on the moon and it has to do some operation. That is a particular task. How this task has to be done? It has to be planned first. Simulations has to be done. That is planning. Problem solving. How the problem is to be solved by making use of various algorithms or various formulas, etc., etc., etc. So understanding the moment the teacher teaches the particular students or any course, the student understands the topic. Similarly, how the machine will understand. See, one thing you should remember: the machine understands only two things. One is zero and one is one. There's only two things. If you have to teach the machine, you have to teach him in zeros and one only. That's why that compilers, etc., all those things comes into the picture. So this is the 15 important goals of AI in robotics. Of course, in the tomorrow session, the day after tomorrow sessions, I would like to go deep into this AI and robotics with practical examples. Okay, so this are robots and artificial intelligence the same? Of course, two are slightly different. So the first thing is to clarify that robots and AI are not the same. In fact, the two are slightly separate. So I have created a Venn diagram. Robotics is one circle, another is a circle is artificial intelligence. Combined, this is called as artificial intelligent robot. That means systems working with intelligence is called as artificial intelligence robots. So AI robots are the bridge between robotics and the AI. So these are the robots or machines which are controlled by AI and having a lot of machine learning algorithms. So robots are not artificial intelligent. They are deaf, dumb, and blind. They don't know anything. Whatever you instruct them, it will do accordingly. So the modern day robots, the sixth generation of robots, when you take the computers also, if you give the wrong data, what it will do? It will give you the wrong result. The computer will process and give you the wrong result. Wrong data, given wrong result. But the sixth generation of computing systems are what is called as the thinking computers, like humans. If you give the wrong data, it will think and give you the right result. Similarly, the sixth generation of robots are called as the thinking robots, working with machine intelligence, swarm intelligence, smart intelligence, etc. How do you incorporate artificial intelligence in the machine? By making use of more and more number of programs. Of course, now machine learning. So machine learning is an important application of AI, and that provides the system the ability to automatically learn and improve from experience without being explicitly programmed, without human intervention. So the teacher teaches the student a particular subject, say signals and systems or digital signal processing for say 3 credit course or 4 credit course. After the course is over for 4 months, the student will become fully thorough in that subject and he will be able to solve any type of problem. Similarly, if the same problem has to be attacked by a machine, it has to be taught first. So that is where the machine learning comes into the picture. So it should perform without human intervention. You give any type of problem to the machine, it should solve. Like how it is given to a human being, he starts solving the problem. So more and more number of thinking algorithms has to be incorporated so that the machine will become intelligent and it will be able to solve a problem on its own. So this ML, machine learning, focuses on the development of computer programs that can access the data and use it to learn for themselves. Learning. One of the best learning algorithms is the ANNs, artificial neural networks, and the CNN, that is the convolution neural networks. So it is an application of AI that provides systems ability to automatically learn and improve from experience, perform like humans. It enables the computers to tackle the task that has been given. Until now, only that has been carried out by the people. Still now, people used to solve the particular problem. Now, instead of humans, the machines are being installed to solve the particular problem using their machine intelligence. So the primary aim of this ML is to allow the computers learn automatically without human intervention or assistant and adjust the accordings, adjust the actions accordingly. Like how we human beings, if you take the human beings, these human beings are called the super robots because human beings has got a very good adaptability feature, thinking capability, decision making capability. Those concept machines are not having. Machines are deaf, dumb, and blind. We have to give them machine intelligence, all sorts of Kritaka Buddhi they call. In Kannada, the artificial intelligence is called as Kritaka Buddhi. How much amount of intelligence, the learning algorithms you incorporate into the machine, that much intelligence a machine will become. So the other sense that machine learning means there is nothing but like how we human beings have learned the programs that what you have designed has to be executed by the machines in order to do a particular task. So in the world, currently in the world, five current learning applications in robotics are the computer vision or pattern recognition, imitation learning. Imitation learning means learning by looking at others, like master slave programming. Then supervised and unsupervised learning. Supervised learning means first you have taught. So once you are taught, it will become perfect. Like best, the teacher teaches the student. Okay, the teacher teaches the student, and the student will become thorough in that subject, and any type of problem he will solve. Unsupervised learning means the teacher has not taught the student at all, and suddenly a problem is given to the student and he has to solve. Like a teacher comes to the class and suddenly gives a surprise test. So unsupervised learning means even though you have not taught the theory to the particular machine, it should be positioned to solve without being taught. That is unsupervised learning. Assistive in medical technologies. Normally, this machine learning algorithms plays an important role in this medical and assistive technology, which I will be explaining in the next sessions. Multi-agent learning. See, this AI is single core. That is a unique core. I can say that it is a unique processor, single this one. Suppose you had to go for multi-agent learning, means learning in groups. One robot is used for manufacturing a particular product or to do a particular operation or a process. If multiple robots are there, n number of robots are being joined together to do a particular topic work, then it is called as multi-agent learning. One simple example I'll give you. Say for example, in a floor, in a field, if only one farmer is using his systems to till 1 acre of land, it will take 1 day. On the other hand, if 10 farmers are used to till the same 1 acre of land, then what happens? The time will be reduced and more number of people will be working. That is called as multi-agent learning or working in groups. Single agent learning, multi-agent learning, working in groups. That another coincidence is there. Similarly, you can say, take in any company in the software industry. Say the entire project will not be done by one particular software engineer. The project head will be there. Below him, so many project members will be there. Project leads will be there. Team leads will be there. Each one will be doing one particular coding, and the entire thing will be collaborated together, joined together to form the overall execution of the project. That is what is called as multi-agent learning. That is in the company, human beings are used to design the software, okay, and to deliver a particular prototype of the work. Instead of human beings, if machines are involved, how will they develop this type of culture, this type of technique to work together, machines in work? That's what in the previous one of the slide I have showed. This is a CAD CAM sim, computer design, computer manufacturing, computer integrated manufacturing. Entire system is automated. They will learn by themselves because it makes use of the advanced ANNs, artificial neural networks, where the training algorithms are there. So it has been trained. I think many of the researchers around the world, are MTech students, PhD students, research scholars, faculties, are using this ANNs, CNNs, are now the recurrent convolution neural networks, ANNs, the CNNs, and the RNNs, to train the particular system, so that any type of work is given, any type of problem is given, it will be in a position to think, judge, capability to decide, and arrive at the solution. That is multi-agent learning, working in groups. Of course, this I will be explaining with numerical examples and with one design prototypes in the next seminars. Okay, now as I all told you that the robots comes falls under the category of soft automation. Okay, all the modern day robots are controlled by computers or microcontrollers, which is the brain of the robot. See, commands or instructions that will tell a mechanical device or an electronic system together as robot what task to perform. See, we human beings communicate with each other in our own language, English, Hindi, Kannada, etc. How will the robot communicate with each other? That is what is called as programming. Programming of a robot means to communicate with the robot in its own language. That is teaching a robot how to do a particular task in its workspace effectively, and that consists of various types of programs, subroutines, function calls, etc. Or you can also define it as a set of instructions written in any language, high level or a low level, for the system to do a particular task. Even if you write in high level, it will be broken down into lower level using interpreters and compilers. As you all know that robots in the machines, computers understands only zeros and one. So top 25 robot programming languages: C, C++, Python, Java, MATLAB, Scilab, LabVIEW, .NET, list processing, Visual Basic, VAL, PL1, PL2, then robot programming language, microcontroller language, script language, then lead through programming, then of course it is one, that is 18 powered and manual, the master slave programming, then the Prolog and the Rail R programming. Prolog is the topmost AI language in the world. Prolog, Rail, robotic artificial intelligence language. So these are some of the top 25 robot programming languages which are used to communicate with the systems. And before you design any system, you need some specifications. You go to a company, ask, give me a product. You will tell what specification do you want. Similarly, if you go to a company and ask, I want a robot, you will tell what specification of the robot you want. What are the specs? Give me computer similar to computer specifications like number of axes, degrees of freedom, what is the load carrying capacity, speed, etc. What is the type of workspace, and what is the reach and stroke, operating environment, what is the type of programming, etc. These are the robotic specifications. And one of the specifications is degree of freedom. So we can define it as a maximum possible ability of movement in the 3D space. The number of independent directions in which a robot can move in the 3D space is what is called as a degree of freedom. Example, automobiles, aeroplane. See, an automobile can move in only XY plane, a car or a bus, so 2 degree of freedom. An aeroplane has got 6 degree of freedom because 3 for positioning, and when it is in the 3D space, it can orient itself, yaw, pitch in the roll. A mini drafter has got 3 degree of freedom. As I already told you, human hand has got 26 degree of freedom. Any industrial robot should have minimum 6 degrees of freedom. 3 for positioning, 3 for orientation. So it is not necessary that a robot should have all the 6. Minimum 4 is sufficient. 3 for positioning and 1 orientation. You have seen the 2D movies, ordinary movies, 2D and 3D. Similar to that. As I told you, that airplane, it's got 3 degrees of freedom because an object lying on the floor, x comma y, an object lying in the space, x comma y comma z. So that is positioning. If you want to orient it, another 3 degree of freedom, yaw, pitch and the roll. So totally 6 degrees of freedom are needed for any particular object to be in the 3D space. So those three can be clubbed into major axis for positioning and minor axis for orientation. Coming to the classification of robots, robots can be classified on the basis of drive technology. Electric robot, hydraulic robot, pneumatic robot. Electric working with current, hydraulic working with fluid, pneumatic working with compressed air. Based on the workspace envelope or the workspace. You know, in mathematics, there are three types of coordinates. One is a Cartesian coordinate, one is a cylindrical coordinate, and the polar or a spherical coordinate. Okay, workspace means the area in which the robot can do useful work. The border of the workspace is called as the workspace envelope. And based on the motion, it can be classified into continuous path, pick, end, place, point to point. Coming to the intelligence of the generation, it can be classified as first generation, second generation, up to the fifth, sixth generation of robot, like how computers evolved in generation. And this is a pneumatic robot or hydraulic robot, which was designed by me and my students in the earlier colleges. If you admit pressurized air, pneumatic. If you admit pressurized fluid, it is nothing but hydraulic. There will be a piston. That piston is used for movement. And this is also another project which was done by my MTech students in the earlier colleges, and this is an electric robot. The electric robot, for the movement, we make use of servo motors or nothing but the stepper motors. They are nothing but the drive mechanisms. So, okay, convert electrical energy into the mechanical energy, which is nothing but the rotation or nothing but the linear motion. Coming to the workspace, it can be classified into Cartesian. You see, if you visit this flyover or any industry shop floor, you can see something which is moving along x-axis, something which is moving along y-axis, something which is moving along z-axis. So 3 degrees of freedom for positioning, 3 degrees of freedom for orientation. Okay, coming to that is a rectangular coordinate system. Coming to the cylindrical coordinate system, which is nothing but r, theta, and the z. So that means it is having two linear motions. It can move in and right, y-axis. It can move up and down, z-axis. So as a result of which, from the top, if you see, the workspace is nothing but a coaxial cylinder, not a solid cylinder. It's a coaxial cylinder. So this is called the cylindrical coordinate robot, in which one joint is rotary. In the earlier case, all the three joints were linear. Here, two linear and one rotary. Coming to a polar coordinate robot or a spherical coordinate robot, here two are rotary, one is linear. If you see the battle tank, the warfare tank turret, that gun is there, na? That gun resembles the polar coordinate robot. So that gun can rotate around the base hemisphere. That gun can move up and down, in and out. As a result of it, the workspace is nothing but a hemisphere, polar coordinate robot. And here you can see there are. See, in the first case, the workspace was a cube. In this, it is a cylinder. Here, it is a hemisphere. Now, if you have all three joints as rotary, all the three joints are rotary, then it becomes what is called as an articulated robot. The word articulated in the sense is a medical term which is used for jointed. So if all the three joints are rotary, it becomes, the workspace becomes a crescent shaped. You can see there, in the first case no rotary, in the second case one rotary, in the third case second two rotary, in the third case three rotary. As a result of which, a number of rotary joints goes on increasing, the workspace becomes more and more complex in nature. Coming to the pick and place robot. Now what is a pick and place robot? It is used for normally pick and place of electronic components onto a printed circuit board. Now the robot picks up an object from one point, keeps it at another page. Who is going to give that pick and place point? By the user. Next, coming to the point to point robot. The robot moves through a series of points and work will be done. And coming to the continuous path robot. The continuous path robot itself says the user will specify the path along which the robot has to move. Once the user specifies the path, the robot will be moving continuously along the path. And when it is moving continuously along the path, care has to be taken to see that each and every joint is controlled, every motor is controlled. Hence the name continuous path robot or a controlled path robot. Okay, point to point robots. Robots making spot welds on an automobile car. Start from one point, do a spot weld, go to another point, do a spot weld, go to another point, do a spot weld, and come to the home position or the resting position. Continuous path robots used for spray painting. Who is going to give the area about along which the robot has to do the spray painting? The path will be specified by the user. So robots used for spray painting on an automobile. Coming to the generations of robot: first generation, second generation, third generation, fourth generation, fifth generation. Now we are in the era of sixth generation. Expert systems. Expert systems means systems which can work like humans in all fields. First generation remote control, second generation autonomous, third generation network, fourth generation AI system, fifth generation smart intelligence, or they also call it as the swarm intelligence or the thinking system. Now everywhere you heard of smartphones, smart systems, smart intelligence system. Is the era of smartness. Smartness is being incorporated. Smartness is nothing but extension of AI. You can see the man versus the machine, man versus the machine. Coming to the last topic, that is applications of AI in robotics. Robots uses and applications are innumerable. So nowadays they are used in almost each and every field of science, engineering, and technology, industry, and in even our domestic life. That is our day-to-day life. If you see in Japan, the population of Japan is around 5 crore. In fact, there are around 8 crore robots in Japan. That means it's almost double the population of the Japanese. In every house, Japan is using the robots. Japan, you can say, they are the father of robotics. Mainly, the users, even in any, all domestic, the robot does the cooking, etc. Makes the coffee and brings it to the paper, brings the newspaper, etc. So, mainly, the uses of robotics can be classified in four main areas. One is in the production, which is the industrial automation, that is manufacturing a particular product by automatic means without human intervention. Okay, and then aid for the handicapped. Suppose if that's for medical application, if one hand is not there, one leg is not there, you can put an artificial hand or call an artificial leg. That is what is called as telethesis, orthothesis, exoskeletons, etc. Hostile and hazardous environment. Hostile environment means the environment in which we human beings cannot work. Example, the space exploration, the Mars Pathfinder, the Chandrayaan, the other underwater exploration. For example, if you see this Titanic movie, in the starting, what happens? An underwater robot comes down, goes down below the earth, seabed where the Titanic has sunk, and takes the photograph of that lady and brings to the top. Hazardous environment which is very dangerous to the human being. Example, in steel industry, molten iron which has to be handled. There you can make use of this robotic systems, domestic purposes, used in the daily household purposes and in the movies, etc. So major industrial applications I have mentioned here: loading, unloading, press loading, all the mechanical processes, painting, milling, PCB design, foundry, inventory control, then packaging, material transportation, inspection purposes, lathing, press work, deburring, gluing, screwing, etc. Then to manufacture, then to test the quality of the finished product, for inspection purposes, to for finding out the manufactured imperfections, etc. What are the advantages? See, these advantages of industrial automation are: the productivity is increased, cost per unit of the finished product definitely will be reduced, and you can meet the supply and demand, and good accuracy will be there. Quality of the finished product, take the car, foreign cars, how the quality of the finished product is there, and ability to work in hazardous area, stability and improvement in the quality of the product, and humanization of working life, ability to work in hostile environment, reduce labor cost, FMS, flexibility in manufacturing, prevents accidents and occupational diseases where humans has to work, improved quality of production areas, ability to withstand severe working condition. Industrial robots release human from hazardous and unhealthy working condition, reduces psychological stress, and the nation's economy increases. Nation economy will be improved drastically, production rate will be increased, the companies will prosper, etc. How much advantages of industrial automation is there, and one major disadvantage is there. That major disadvantage is it displaces the human labor. Since it displaces the human labor, what thousands of people will be doing a work, the same work will be done by a machine. So the unemployment. So there is some pros and cons. We cannot help it. And so that is one of the major, and of course, it's not suitable to a country like India where it is human populated. The population is very very high. Now this industrial automation evolved into the 4.0. In the first stage, in the earlier stages, in the first 25, this one, first 30 years, from 1900s to 1930, it is industry 1.0. From 31 to 60, 2.0, 60 to 90, 3.0, like that it goes on like that. Now the industrial revolution, the fourth industrial revolution, 4.0, what you call, is nothing but the ongoing transformation of the traditional manufacturing and industrial practices combined with the latest smart technology, and it focuses on the use of large scale machine to machine communication and IoTs, the Internet of Things, like smart industry. We human beings, in the earlier days, we used to converse with each other, workers in the factory. Now machines are kept, machines are placed instead of human beings. They will make machine to machine communication, and they use wireless means, the Internet of Things, to provide increased automation, provide communication, self monitoring, as well as smart machines. that can analyze and diagnose issues without the need for human intervention. Just program it and leave it. Any type of product will be manufactured. That is why that is what is called as the industry 4.0, fully automated industry. As I told you, in Japan, the Mitsubishi company was fully automated. Entire there are no human beings at all inside. There's only couple of managers controlling the systems at the nerve center. Entire place is being automated. So 4.0, what is that? Called a smart industry. Most popular topic today because of the big influence in manufacturing, digital technology, what is called as virtual technology, focused on creating smart environment, focused on creating intelligent product, processes, procedures. Essence of industry 4.0 is the internet of services and the internet of things. Now, what is happening is the computers and automation, they are coming together. The cyber online systems that integrate communications, data analytics, and these systems will transform the traditional particles plants into small factories, work rigorous, work without any human intervention, boardlessly, tirelessly, etc., etc. So this is how the industrial revolution took place. First, second, third, fourth, and we are in the industry 4.0. 4.0. That's what I've shown you, a graphical representation. Automatic robot simulation, system integration, IoTs, the additive manufacturing, then augmented reality, the big data. Then coming to the another one, cloud computing, the system integration, the 3D printing, the cyber security, the autonomous robot simulation. First, everything is designed using in the simulation. Once it is successful in the simulation, then it is transformed into the reality stage using the autonomous robot. Nowadays, you see any product is your product manufacturing is done using 3D printing technology. A lot of students are doing products on 3D printing technology, and this involves a huge amount of data. Since it involves a huge amount of data, so data analytics, big data is coming into the picture in this industry 4.0. How this industrial revolution took place from 1.0 to 4.0. Of course, today it is digitalization. The future is nothing but personalization. That is the fifth industrial revolution. First, mechanization, as I already told. Then, with the introduction, with the invention of the electric, this Alvide, Thomas Alvide is in the electric bulb, the electrification. Then automation took place in the 70s using electronics and computers, using VLSI concepts, etc. The mainframe computers, and then the globalization took place, and today it's the digitization. Introduction of connected devices using Internet of Services, Internet of Things, data analytics, AI. All these are incorporated together in order to manufacture a particular product without human intervention. That is self-automation. The future is nothing but personalization. It will be focused on cooperation between man and machine, like how man and man is conversing now. Machines and machines will converse with each other and do the work. That is called the future automation. A day will come in the future automation where everything will be on a palm top, or nothing but a mobile. In a mobile itself, now you can do huge amount of automated automation activities, maybe banking process, or maybe controlling from mobile in a field, how to switch on the water pump, etc., irrigation purposes. All these will come in the industry 5.0, which is full-fledged total industrial revolution working on a simple smartphone. Now, coming to some of the industrial applications at the end, you see this Intel motherboard. The motherboard which is manufactured by the Intel company is entirely automated. No human beings. Do you think that yeah, human beings will take one resistor, keep it there, do the soldering? If you do the soldering, then that I will show you that some red color. There will be a dry solder. The machine solder will be there. So these are called as a SCARA robots, that is selective compliance assembly robot arm during pick and place of electronic components onto the motherboard. So what does the robot do? It picks up an IC component, keeps it on the top. Then it keeps another component, resistor, inductor, keeps it on the IC chip, keeps it on the motherboard. Then below, a series of wave soldering machines does the wave soldering, and that if you see, the wave soldering will be triangular in shape. It won't be a dry solder. Like that, every 10 minutes, an Intel motherboard will be rolled out. That is full-fledged automation. once the Intel motherboard is being manufactured, do you think that it will be inspected by human beings by using multimeters and all? No, that is also inspected by making use of image processing system or the pattern recognition or the computer vision. All the manufactured motherboards will be coming on a conveyor belt. The image processing system or the computer vision system takes the snap of the motherboard. It identifies whether it is a faulty motherboard or it is a good motherboard. If it is a faulty motherboard, it takes the motherboard, puts it on a reject bin, else it allows it to pass. Then a machine will be there, it will put the seal, tested, okay, go for dispatch. Then once it is being tested, then again it will be used for CPU manufacturing in an assembly in a Toshiba plant. You can see all the motherboard parts, SMPS, etc. They are being assembled assembled by making use of computing systems. Now I can come into some industrial application. Here I am showing a robot doing a spot welding application using an articulated robot. Here you can see the tool is there. Industry, what they will do, they will attach a tool. Here it is nothing but a spot welding gun. That spot welding gun is used to do a spot weld in a particular part. Now that tool they will remove and they'll put vacuum cups. It's used for picking up vacuum or pneumatic gripper using the glass for the glass sheet. Glass sheet cannot be picked up by the sides, correct? No? So all the glass sheet will be end to end. Like how in the house, what you do using vacuum, you fix a particular device on the wall and put a calendar. Similar to that, vacuums will be there in the cup. That vacuum will be created by suction, and once suction is created, take the system very near to the glass, pick it up, and come back and place it in the required direction. Now, robot doing a drilling operation in a truck. Now what happened? That spot welding gun they will remove, attach a drill bit. It becomes a spot drilling operation. Then again remove that tool. You put a buffer. Like it is used to remove the manufacturing imperfections. Some sharp projections will be there, no, in the manufactured, like watch buffing. So buffers are used to make the what you call the manufactured products smooth. Then robots used for grinding operations using grinders. Now remove that tool and introduce a grinder as a tool. It is used for grinding, cutting a particular part. Robots placing manufactured cartoons on a conveyor belt, used for packaging purposes, used for a palletizing robot, keeping one above the other. Like see, otherwise in, for example, if you take in a truck comes a lot of rice bags will be there. So each worker has to take it on a bag, go and dump it. Instead of that, robots can be used for that is what is called as a palletizing and a depalletizing, putting inside and removing it. Then robot used for placing manufactured parts on a roller. Puma robots used for manufacturing small industrial robot. Puma is the first robotic company in the world. ASIA robots laying down adhesives. Then robot gauging of the manufactured part. There you can see that a part is being manufactured, a cube is being manufactured by making use of laser gauges. It is going to find out the dimensions of the manufactured part. Say for example, the same part is being given to a human being. You ask him to find the dimensions. What he will do? He will take a scale or a vernier calipers and he will measure the length is so much, the thickness is so much, the width is so much. Then he will keep it on a weighing pan and say the weight is so much. Now instead of the human beings, we can make a system, the robot itself, to find out the dimensions of the specifications of the manufactured part by making use of laser gauges. Once it finds out the dimension by making use of automatic gauges, that information will be fed to the computer. The computer will make a nameplate. That nameplate, once it passes, will be printed onto the specification. That is how the automatic inspection takes place, used for removing dirt inside the machines. A work cell in which a robot is used for transfer of parts, CAD, CAM, SIM. That's what initially I have told you. See, one robot does one particular job. It keeps it on the place. Then that manufactured part goes to the another robot using a conveyor belt. There, that robot takes up that part which was being, say, this first fellow would have done some drilling operation. The second fellow will do some name plating operation. Like that, every 5 minutes, product will be finished. Product will be rolled out. These robots resembles the workers in a factory, right? And all are integrated. That is computer integrated manufacturing. A team of Unimate robots assembling the car engines for storing car panel doors. Robots mounting doors on the cars. RCR robots doing spot welding.
two robots spray painting underneath the car body. Another view of a spray painting operation underneath a truck in an assembly line. Do you think that the human being will tell, hey, Mr. Robot, you spray paint this amount, this area of the car? No, entire car is simulated on the on the computer using simulations. There on the computer itself you'll be doing the painting in the simulations. Once it is successful in the simulation, then you will transform into the reality state using this particular that is what is called as real-time implementation. Then robot installed in seat into a car, then automated wheel mounting system using robot. See this robot, two robots which are there, which is in a Toyota manufacturing plant in Japan. It can fix up 1000 wheels a day. And you can say automatic vision system used for fixing front glass cup plates, windshield for cars using vacuum grippers. It takes the windshield, keeps it on the front part. Then Honda City car manufacturing assembly line. As I already told you that the assembly line of Honda City is around 3.5 kilometers. Starting the chassis, left side 100 of support, right side 100 of support. First the chassis comes, then one robot fixes the wheel on one side, another robot fixes the wheel on one. Next it goes forward, another tightens the nut and bolt, another fix the seat. Like that, every 5 minutes car will be rolled out. This is what is called as industrial automation. Remember the how much programming skill sets is needed. See, if one robot plays a mischief, instead of doing a spot weld at one point, it just does 1.2 and some slightly besides. The entire car which has come out in the stages, it has to be thrown out. This is the type of programming that these are all real-time programming. It's not the small programming what we write in our laboratories. Write a program to add two numbers, etc. All it is nothing but they all make use of programmable logic controllers, etc. Toyota manufacturing company assembly line, and this is a smart factory. You can see all robots on one side, left side, right side. Particular each and every robot is being dedicated to do a particular job. This is another view of industrial automation where the cars are being manufactured. Another view of this one. I'm going to just show for 2 minutes and how a car is being manufactured automatically. You can see the beauty of the machines. Just a small break. of another robots which are used for spray painting. You can just see an industrial plant. Sorry, just there's yeah, come back. Yeah. Coming to some of the movies, you can see robots plays a very prominent role in some of the movies, like as a Terminator 2, Robocop series, iRobot, the Iron Man, the Forbidden Planet, the Transformers, the Star Wars, the friendly robots RT, R2D2 and C3PO, which saves the princess from the clutches of the enemies, and the Terminator 3, the rise of the machines, the day Earth stood still, and our own Indian robot, the robot Chitti, Rajinikanth, it's robot 1.0, 2.0, which plays. There you can see that even the robots have got feelings like we human beings. In the movies, the robotics in the Jurassic Park and the space explorations, then the scientists developing the Pathfinder in NASA, then the Chandrayaan 2, then you can see the Pathfinder, Marska Pathfinder, it is lying still there. The communication link between the Marska Pathfinder and this was disconnected, as a result of which the finder is still lying there only. It hit a rock. It hit a rock, and it is the system got disconnected. Halfway to the planet Mars, bionic fiction becomes fact. See, nowadays what is happening is scientists are developing a functional bionic arm that promises to aid the amputees the world over. If any human being is not having an hand, an artificial hand can be designed and it can be put. That is called as a bio-inspired artificial hand with sensory systems that can provide patients with active feeling. And each finger tip, micro motors are being kept. The micro motors rotation is such that it is having stepper motors, micro steppers, 1 micro degree per step. You cannot see the movement like that. Tuck, 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 it starts moving. And this is being a handy invention which is being designed by a group of scientists from the Israel. It's called computer controlled prosthetic hand. Okay, it makes use of the master slave programming. Master hand, he just moves his fingers. The robot also moves his fingers, and when it is moving, it memorizes all the instructions that what the human is feeling and plays back. Then it's called the replay or record back robots. Then robot warriors. Robots can be used in defense also. That unmanned aerial vehicle makes these robots more dangerous than any human terrorist. Or it is just even 5 to 6 mm in size, centimeters in size. Very small, like the honeybees and all. Robots to guard border. In fact, our government of India is thinking of deploying a large number of robots designed from the DRDO and keeping along the Indo-Pak border so that they can save the lot of human. The moment this robot tracks any infrared material which is entering into these things, the tunnels and gun will be activated and kills the enemy. Okay, that is one. Japanese award enemies robots, droids and the robots, and man versus machine. We have to be very, very careful. Day by day, the machine intelligence is becoming more and more stronger. A team of international scientists believe that the ethical division between humans and robots must be made now. Before it is too late. robotic arm shields dogs from radiation. In All India Institute of Medical Sciences and in our own Bangalore Kiran Majumdar Shah Hospital, robots are being used for performing surgery. Robots' rights, yes, they should be given fundamental rights, like how we are having fundamental rights. This is a clip from a Hollywood movie, I Robot. Yes, robots are going to get rights by 2056. The world, the United Nations confirms by that time. Your brain is being outsourced. Experts are mixing and matching artificial intelligence and genetic programming to create a species of software that will comment with the complete with the human beings. Now, a new type of programming has evolved since the last 4 or 5 years called as the genetic programming. Genetic programming is one of the advanced type of programming which solve the age-old problems of of getting a particular work done. Say, for example, here you can say there is a machine and there are different color cubes, and instead of that machine, if a particular ball is there and if the person tells pick up the red color ball, keep it in the bin, pick up the green color ball, keep it in the bin, okay, he will do it because the human being can recognize the color concept. But in the same place a machine is there. If a machine is there and if a machine is being instructed, pick up the red color box, keep it in one bin, pick up the green color ball, keep it in another bin. How will you make? This is the most important task to perform. How will the robot perform the task? The new advanced type of artificial intelligence and convolution neural networks and genetic programming makes this concept very easy. This genetic programming also can be used to perform advanced operations like thinking and all. Robots can be used in warfare to perform surgical. If a wounded soldier can be brought up to the surgical table and he can be operated by making use of one particular person who is staying on thousands of miles in the hospital, and a speech processing robot just inform, say, hey robot, go and do this particular job. The robot will do that particular job. These are some of the around 25, more than 25 systems which were developed by me and my UG and PG projects. And this is one of the beautiful project which was done in Mumbai, Father Agnal Vashi, where I was working way back. And every year I used to take a group of students to IIT Bombay for that Yantriki festival. This was way back in 1999, where a group of my students in 99 went to the IIT Yantriki festival for presenting a robot which is moving on the water. And of course, this was my MTech project which was done. I had an opportunity from IIT Bombay to present a paper on robotics in Australia, and another one cutting. We had developed a very good indigenous robot for the Baba Atomic Research Center. That is an IIT research scholar and a few VJTI techies come together to develop an indigenous mobile robot that promises to be a great help to the industry. And this was another one. And some of the textbooks what I have written, which has gone up to the 5th edition, volume 1 and volume 2, and another one small book which has gone to the 3rd edition. And you can see recently in one of the schools in Bengaluru, a robot teacher, the teacher is nothing but a robot. You can see here the robot teacher. A robot teacher in a Bengaluru school. It was recently inaugurated on the Teachers' Day. The robot teaches each and every subject, whatever subject you give, it will be teaching. It will also answers all the queries to the questions by the concerned students. From Indus School in Bangalore. It teaches physics, chemistry, mathematics, and what the student is asking questions, it answers each and everything because all the answers are being stored. we can also make use of these systems in some competitions. And the Robo Cup, you can see with the Robo Cup. This is what is called as IBO, the artificial intelligence robot what the Japanese had designed. This is one of the beautiful work when I was doing my research. When I was doing my research in IIT Bombay, during my coursework time, I had got an opportunity to take that particular subject, robotics and automation, which was one of the coursework subject, and lot of questions, lot of assignments I used to do on this particular robot, which was sponsored by Baba Atomic Research Center. And you can just see a cut. It was the first indigenous six-legged robot designed by IIT Bombay. That is what is that is Nataraj. And you can see here the robots which are used for putting a sealant, and another robot which is used for putting sealant, and for laying down adhesives, gum. So on which on the top of which another plate will be put, and a four-legged robot. Of course, this is also designed by us, and this is also as one of the UG project. It can climb up the rough terrains like a battle tank. And this was the one which I was telling, the Nataraj, the six-leg robot developed by IIT Bombay, which I was a part of this. And more than 50 UG students, around 30 MTech students, and 4 PhD students had worked on this particular model. It was developed in the mechatronics lab in IIT Bombay in the mechanical department. You can see each and every part was indigenously manufactured in the workshops, and all the electrical and electronic components, circuitries were designed. Remember, this was in way back in the 2001, exactly nearly 20 years ago. Of course, the inertia, it was like, see, you can see that like a horse's gait. Three legs will be lifted, it keeps, and another three legs it will be lifted, kept, like how it moves in a horse's gait. And you can see the yellow color one. They are called as the pressure pads, like how we human beings keep our leg on the floor, and it will be sensed. Similarly, that pressure pads thinks that the floor has reached and it stops further pressing. Pressure transducers, what they call. Three legs up, three legs down, like that. It's just swirling its this one, going in the forward direction. It's just swirling its legs. Now the robot is going down. See, when it is going down, we can see that the weight and the gravity is acting down, so that it will be very easy. And when it is moving up, the upward force has to be greater than the downward force. The inertia force has to be more. For that, a high torque rating motor has to be used. You can see when the robot is moving up, it is crying and lifting. Normally, in fact, we took around 7 to 8 months to make this lift up. Like how we are moving in a lift, and it is coming down. The moment it is coming down, the sensors will be actuated. Transmission systems, the gates. You can see here all the parts have been manufactured in the lab only. And this is our team. In fact, I'm standing at the back. In fact, this was one of the in the coursework. I designed couple of mathematical algorithms for this particular system. And this is also one of the UG project what we have developed. And this is a very beautiful this one, the six-legged Boston Dynamics. Being involved, we can see this Japanese Oda Asimo robot, which gets up, stands, and dances to the tune of the Japanese music. Yeah, and you have to be very, very careful with these machines, where one of the ethics and the safety comes into the picture, robot safety, which is coinciding with the one of the laws of robotics. Beware of artificial humans. You have to be very, very careful with these artificial humans. It so happened that one day in Japan, a worker was stabbed to death by a robot. It was not the fault of the robot. Why this fellow should go and stand in the place where the object was to be picked up? So the robot thought that he had gone for surveying or something and he was standing there. The robot thought that this fellow was the object and picked him up and pinned him against another machine. That's what it is said. It is one of the first record. If a 37-year-old factory worker was stabbed to death by a robot that started pinned him against another machine. So it be very, very careful. Therefore, wherever industrial machines are there, robots are there, we have to barricade them. Safety is very, very important. That's what I wanted to reiterate. A day might come when these artificial humans will definitely overtake natural humans, and it has already come with this smart intelligence. The machines are becoming more smarter and smarter. They are trying to compete. They're trying to compete the humans, like how you have seen in the movie Terminator. A day might come when these artificial humans will naturally overtake humans, and it is already. And I would like to iterate with the future applications like the medical examinations, the underwater explorations, the surveillance and the guard duty, firefighting, household robot, underwater exploration, lab automation. All these applications will need to be more intelligent in order to make rapid decisions based on the current sensory information. In tomorrow and day after tomorrow, I'll be explaining some of the concepts which are relating to the nano robots which are used to cure the therapies, the cancer treatment, and that too the most contagious disease like coronas. In the conclusive remarks, I would like to conclude this webinar. A brief automation concepts I had given with its types and what are the advantages and what is robotics, what is AI, a glimpse of AI in machine learning would be covered tomorrow and day after tomorrow. What are the goals of AI, the 15 goals, and what are the laws of robotics, and what are the specifications, the anatomical raw parts, and what are the programming skill sets that are required, and what are the applications of robots, where you can find. Just here I have concentrated on the macro robotics. So tomorrow I'll be concentrating on the micro robotics and future on the nano robotics technology in the next 2 days of the FDP seminar hosted by Vidyarthaka College of Engineering, the E-Electronics Department. Thank you, my dear participants, for a patient hearing. Now I am leaving the session to the host so that they can ask any of the few questions what I would like to answer. Thank you, one and all.
Thank you very much, sir.
Thank you, sir. I think I might have taken around 2 hours.
Yes, sir. That's
If
okay.
there are any questions in the chat box, you can take those chat box questions and I will be in a position to answer. Or if there are no questions, you can conclude and I can rejoin tomorrow.
Yes. Actually, there are no questions. If questions are there,
Okay.
we'll take those questions tomorrow, sir.
Okay, no problem. No problem. No problem. So
So
you
I
would
would
like
like
to
to thank, yes, sir.
Okay.
I would like to thank all the participants also for active participation in the presentation. And I would like to thank our today's speaker, Dr. T.C. Manjunath, sir. Uh, we'll meet tomorrow, sir. Thank you.
Okay. Thank you, one and all. Thank you, the entire team of EC department and headed by electronics HOD Dr. Patil and the principal Sadashiri Gowda, sir. Thank you, one and all, for a nice year. Thank
Thank
you,
you
sir.
very much, sir.
Thank you, sir. Thank you, sir.